Hello and welcome to this video. In this video, we are going to be generating the pipes to come from the top of the screen as well as the bottom. At the moment, they are only being generated from the bottom of the screen. So we want to have two sets of pipes, one coming in from the bottom and one coming in from the top. So at the moment, we've got the screen, which is the blue rectangle, and then we've got the pipes. So we've got the pipes coming in from the bottom. So I'm going to add a top pipe that will be spawning from the top. And we're going to also change the position of the top pipe. So at the moment, the bottom pipe is positioned in the mid-top position. So the top pipe is going to be positioned in the mid-bottom half. And I want to create some space between the pipes. So the green strip here, it represents the spacing I want to provide between the top pipe and the bottom pipe. So I'm going to give it a negative 150, which will be sufficient to create some space between the pipes as they move along the screen surface. To create the top pipe, we're going to implement that inside the create underscore pipe function. So at the moment, the create underscore pipe function is generating the pipes from the bottom of the screen, which is the mid-top position. So what I want to do is create a second variable that is going to store the pipes that are being spawned from the top. So the first thing to do, I'm going to change the name of this pipe from new underscore pipe. This is now going to become the bottom pipe. So I've changed the name to bottom underscore pipe, and I'm going to create a second variable that is going to store the top pipe. I've created the second variable on line number 10 that is going to store the top pipe. The top pipe works similar to the bottom pipe. There's just a slight difference. I want the top pipe to be higher than the bottom pipe. So to do that, I have added this negative 150. This is to create some space between the pipes. Next, because I now have two pipes, I'm going to have to return both of them. So I'm going to change this return statement on line number 11. So on line 11 here in the return statement, we are returning two sets of variables, one containing the bottom underscore pipe and the second containing the top underscore pipe. We have to make some changes to our code, since on line number 11 here, I am returning a tuple. So when you're returning a tuple, you have to unpack the tuple. On line number 63 of my code, where we have the first list here, which is pipe underscore list, because we are unpacking the tuple, we cannot use append. We can't append to a list, but we can extend the list. So we're going to change this from append to extend. So what's happening on line number 63 here, it takes the first list, which is pipe underscore list, and it extends that list by whatever is returned by this create underscore pipe function, which is basically a tuple with two elements. If I run the code again, we should see two pipes, one coming from the bottom of the screen and one coming from the top of the screen. So you can see the pipes coming in from the top and the bottom. If you look closely, you'll notice that the pipes being spawned from the top of the screen are appearing upside down. So we have to flip the top pipes so that it appears in the right direction. So we're going to do that now. We are going to flip the top pipe inside the draw_pipes function. I'm going to add a conditional statement that will check for certain condition and then flip the pipe and then store the pipes that have been flipped in a new variable. So this is what the draw_pipes function looks like at the moment. I'm going to modify this to reflect the flipping of the top pipes. I have made some changes to the draw_pipes function. I'm going to run through the changes with you. I've added some extra logic that will enable us to flip the top pipes in the right direction using conditional statements. So on line number 21, I have an if statement. I am checking if the pipe is greater or less than 512. 512 is basically the total height of the display surface screen. If we take a look at this diagram, only the bottom pipe can reach that level of the bottom of the display surface screen. Only the bottom pipe can reach the bottom of the display surface. So if that condition is true, line 22, I am using the blit method to draw the pipe surface on the screen and also mount the pipe. If that condition is not true, line number 23, I've got the else statement. So in this block, we will execute a different block of code if the condition in the if block is not true. The variable on line 24, the flip_pipe variable, this variable will store a new surface after it has been flipped. Pygame has a function that can flip surfaces. It's called pygame.transform.flip. We are passing into this flip function the surface we want to be flipped. We're also passing in two arguments which are booleans. A boolean is a true or false statement. The first boolean value is checking if we want to flip in the x direction. We do not want to do that, so that is going to be false. The second boolean value is checking if we want to flip in the y direction. This is true, and this is what we want to do. So because we want to flip the surface in the y direction, the condition is going to become true. In that case, we are going to use the blit method on line number 25 to draw the transformed surface on the screen with the pipes mounted. So the new surface, which has now been flipped, is stored in the variable called flip_pipe, and we're using the blit method to mount that with the pipes on the display surface. So if I run the code again, we should see the top pipe has been flipped in the correct direction. As you can see, the top pipe has been flipped in the correct direction as the bottom pipe. Hello and welcome to this video. In this video, we are going to implement some collision detection in our game. Collisions are easy to detect with rectangles. Our bird and the pipes both have rectangles embedded in them, which are invisible on the display screen. So we are going to be using the rectangles that embeds the bird and the pipes to detect collisions. There is a method called Collide Direct that is used to detect collisions. The basic syntax for this method: so you take the first rectangle and then you apply the Collide Direct, and then you pass in the rectangle. You are checking for collision. So this returns either false if no collision is detected, or true if collision is detected. So let's implement some code to do that. I have created a function on line 27 called check_collisions, and then I'm passing in the list that contains the pipes, and each of the pipes are embedded in rectangles. So what this function is going to be doing is going to be going through all the pipes stored in the pipe list, which is indicated on line 28, and then we are checking if there is a collision with the bird and any of the pipes that are embedded in the rectangles. If there's any collision, what I want to do at the moment on line 30, I'm going to print out some text on the console that says collision detected, just to test that the process works. When you create a function, before you can use the function, you have to call the function. So I am calling the function on line number 85, and the name of the function is called check_collision, and then I'm passing in the pipe list. So it will detect if there's any collision between any of the pipes stored in the pipe list. Remember that the pipes are embedded in rectangles. So I've typed in the name of my Python file, which is flappy.py. I'm just going to press enter on my keyboard and then start. You can see each time the bird touches, or if there is a collision, it gets printed on the screen. So if we take a look at the code here on line 30, that's what I have specified so that I can check if there is a collision. We also want to trigger some collisions if the bird flies too high or too low. For this, we do not actually need collisions. We just need to check if the top of the rectangle of the bird is too high, or if the bottom of the rectangle is too low or too far down. It's actually a good practice to minimize the use of collisions. Checking for certain positions using a conditional statement is much easier and more efficient for the game. So let's add that to the code. I have added a couple of lines to this function called check_collision. Line 31, I'm using an if statement to check if the top of the bird rectangle is less than or equals to -50, or if the bottom of the bird rectangle is greater or equals to 450. So if either of those conditions occurs, I want to trigger a collision. Just to test this, I'm using a print statement on line 32, which should print out on the screen collision detected if the conditions on line 31 are met, it will trigger a collision. On line 31, we have to be a bit more specific with the value of this bottom position, because this is going to represent the floor of the rectangle. So we have to specify a position for it to be placed. So for now, I'm just going to save the code and then we can test the game again. So this is the game running. So you can see collisions are being triggered. If the bird flies too high or if it's too low. So if we take a look at the screen now, we can see all these collisions detected being printed. It is detecting collisions either when the bird flies too high or too low. The collisions are also detected when there is contact between the bird rectangle and the pipes. We have used some comparison operators in our code. Comparison operators basically allow you to compare two values. So these are some comparison operator. We use the greater than or equals to. We also use the less than or equals to. Using comparison operators are very important in video game development because it is hard to get exact measurements. For example, the bottom of our rectangle will not be exactly at position 450. Instead, it is likely to be either below or slightly above. Hence, we use the less than or equals to or greater than or equals to in order to check for and trigger collisions. If we were to use the strict equality, which is the double equals to, if we were to use that to check for equality between two values, it will not trigger a collision. This will eventually force the bird to fall down and no collision will happen. It is easier in video game development to use less than or equals to or greater than or equals to comparison operators rather than the strict equality. When you use strict equality, it's very difficult to get the exact measurements. If we take a look at the code here on line 31, we've used the less than or equals to and the greater than or equals to. So we've used these comparison operators to check for certain conditions in order to trigger a collision. Hello and welcome to this video. In this video, we are going to implement the code that will enable us to start and stop the game. So we want to be able to turn the game on and off or activate or deactivate the game. We're going to start off by creating a variable called game_active, and by default we're going to set the value to true, which means by default the game will be active. If this value becomes false, then the game will not be active. The game logic is going to be something like this. So we're going to use a conditional statement to check if the game is active or not. If the game is active, we will run the game logic, and while the game is running, we're going to check for collisions. So when there are collisions, we also want to end the game. So we're going to implement another logic that will end the game. The check collision function is going to be triggered on and off. So when there is a collision, it will trigger the variable game active and that will become false. So anytime a collision occurs, the game will be over. So let's implement this inside our code. So on line number 42, I've created a variable called game_active, and the value I have set to true by default. What that means is that by default, the game will be running. The next part is to incorporate this variable called game_active. We have to incorporate that into the game loop. So inside the game loop, I want to run this block of code which relates to the bird and bird movement, and also this block of code which is the pipes. So I want to run those blocks when the game is running. So what I'm going to do, I'm going to wrap this block here from line 74 to line 80. I'm going to wrap that inside an if statement. So I have added an if statement on line number 74, and I have indented the block of code for the bird and the pipe. So I only want bird to appear on the screen with movement, and only want the pipes to be spawned on the screen only if game active is true. So this block of code here will only run or show up in the screen when the game active is true. So if I save the code now and run it again, nothing should have changed. The code should still run as before. As you can see, the game is still running. Nothing has changed. If I change the value of this game_active variable, if I change that value to false and try to run the game again, it will not show either the bird nor the pipe. All that you'll see is the background for the screen and also the base floor. So I've changed the value to false. So if I try to run the game again, the game will not run. So let's check that out. And you can see here, there is nothing, just the background for the screen and the base floor. You can see there is no birds, no bird, no pipes being spawned on the display surface because the value of the variable called gameActive has been set to false. The next thing I want to do is to use the check collision function to influence or to determine when the gameActive variable has a true value or a false value. So if it has a false value, that means the game will not run. If it has a true value, that means the game will run. So what I want to do, I want to check for collision. So on line number 29 here, if there is a collision with this bird, on line 30, I'm going to replace the print statement with a return statement. So I want it to return a value of false. So each time a collision is detected, I want it to return false, which means the game will be over. Also in this block here, if there is a collision, either if the bird flies too high or if it's too low to the base, I want it to return false, which means it has detected a collision. If the condition in this block is false, that means if there is no collision, and if there's no collision in the second if block, then I want the check collision function to return true. So as long as the value returns true, that means the game will continue to run. But anytime the value changes to false, that means the game will be over. I have made some modification to this check_collision function. So if the condition in this if statement, the first block here, if this condition is true, that is if there is a collision, I want it to return false, and then the game will end. It will no longer run this function. If there is no collision in this block, but if there is a collision in this block, I want the game to also return false, because it has detected a collision when the bird flies too high or too low, and that return false will end the game. If there is no collision detected in the first block here, and there's no collision detected in the second block, then I want it to return true, which means the game will continue to run. Because the check_collision function is going to influence the value of the game_active variable, on line number 79 here, I need to add the game active, which is going to be equals to the check_collision function. So if there is a collision detected, the return value will be false, and it will store that in the game_active variable. If no collision is detected, the return value will be true, and that true value will be stored in the game_active variable. So I'm going to add that game_active variable here. So on line number 79, I've got the game_active variable. It's going to be equals to the check_collision function. So if a collision is detected, the value will be false for the return, and it will store that in the game_active variable. If no collision is detected, then the value of the return for that function is going to be true, and that value will be stored in the game_active variable. So every time the value inside the game_active variable is true, the game will keep running. If the value is false, then the game will not be active. Let's run the game again to check. You can see the game is running, but each time there's a collision, the game ends. With the code at the moment, once there is a collision detected, the game ends, but there is no way of restarting the game. So we're going to work on how to restart the game once a collision has been detected and the game ends. We want to be able to restart the game from the event loop. So if we look at the event loop at the moment, we are already checking for a key down key. So when the space bar is pressed, the bird obviously will jump upwards. So that controls the bird movement. We want to use the same key space to restart the game. So line number 65, I'm going to copy this line and then apply the game active variable to that condition. I have added some block of code from line number 68 to 72. I have also made a change to the code on line number 65. I have added and game_active. So basically what I'm saying, in the first if block, as long as the game is active, there's going to be bird movement. If the game is no longer active, which is the second conditional statement from line number 68, we are checking if the key is pressed, that is, if the space bar is pressed on the keyboard and the value of the game active is equals to false. We want to be able to reset the game_active variable to true. We also want to clear all the pipes that have been spawned when the game ended. So if we don't clear them, they will be cluttered on the display screen. And we also want to return the bird surface back to the original position, which is the center, and the position is 50 by 256. So when we created it, that was the default location we placed it. So we're going to return everything back to the normal. So the pipe list is going to be cleared. The bird is going to be returned to the default position, and we also going to clear the bird movement. So once the game ends, we are resetting everything. So that's what the second block of code is going to do. So now if I restart the game now and the game stops when a collision is detected, I should be able to restart the game just by pressing the space bar on the keyboard. So I'm going to restart the game, and if there's a collision, I should be able to press the space bar and that will restart the game. You can see the game has started and we've had our first collision. So everything is cleared from the screen. If I press the space bar again, you see the game starts again. And if there's another collision, it stops. And to restart again, I just press the space bar and that will start the game again. So we're able to restart the game again every time there is a collision.